Okay, we're back. That was kind of a mess. Okay, good. Now we can actually see what's happening on the other screen. All right. All right, I'm in this problem, like I'm in this prepare. I did React last night. I'll do problem solving. And I'll just pick one of these and go. Okay. Given an array of integers, calculate the ratio of its elements that are positive, negative, and 0. Print the decimal value of each fraction on a new line with 6 places after the decimal. Example. There are n equals 5 elements, 2 positive, 2 negative, and 1 0. Oh, their ratios are... Huh? Calculate the ratios of its elements that are positive, negative, and 0. Oh, so it's 40% positive, 40% negative, and 20% 0. That's what they're trying to say. Print the ratios of positive, negative, 0. The function should not return a value. So there's 1, 2 out of 6 are negative. 1, 2, 3 out of 6 are positive, negative, and then 0 is 1 out of 6. Okay. Okay, that makes sense. Okay, in this case, you don't want to use sets because you do want to count uniques. For some reason, this says I'm offline. Hold on, stupid stream. Yes, sign me in. Let's just go to youtube.com, bradgarropy. No, it says I'm live. Who knows, man? Refresh. All right, dude, it's all over the place. I updated OBS, that's why. Okay. So we don't want to use sets, we just want to use arrays. So we'll say const positive, const negative, and const 0. And actually, they don't even need to be arrays. This is just a count. So we'll start at 0. And we'll essentially just say array dot for each item. And these will all be lets, not consts, because we need to update them. And we'll say if item is greater than 0. This is the positive case. Then we'll say positive plus plus, or I like to say positive equals positive plus 1. We'll do the same thing for the other two cases. And in this case, we'll just return. So this will be less than 0. So this is negative. And it's in that order. Positive, negative, 0, right? Yeah, positive, negative, 0. correct this. This is 0. Cool, so after this, we should have these filled up with the count of positive, negative, and zeros. And now I just think we need to go through and print this out. So we got to do a positive ratio, a negative ratio, and a 0 ratio. Do we talk about what happens if it's 0? Like, what happens if there are 0? We don't know. Okay. We'll figure it out. We got to handle that edge case, though. And then we'll just log out at the end. Positive ratio, negative ratio, and 0 ratio. So it's going to be positive divided by the length of the array. And we're going to have to do some more math here to get it in the right format. This is typically stuff I always have to look up. Okay, we'll run this code. We'll see what happens. Oh, it worked. Sweet. No, I mean, it's... I would say it doesn't work, right? Because it doesn't have... Is it math.round? What are the arguments to this function? No. And this is what I don't know. So it's like JavaScript, math, decimal digits. There's a way to do that. To fixed. Which, why do I feel like this is totally going to cause edge cases? And to fixed takes what? Fraction digits. 6, right? 1, 2, 3, 4. Yeah, 6. All right, we'll see if this works. I hope it doesn't round. Yeah, that works. That's what we want. Okay, cool. Can we clean up this code at all? No, I like it. Let's put the to fixed over here, though. And let's submit it, see if we fail any test cases. Yeah, okay, cool. That all works. Awesome. No, I don't necessarily want to go to the next challenge. Let's go to, like, prepare. Okay. Staircase. This is a staircase of size n equals 4. Its base and height are both equal to n. It's drawn using... The last line is not preceded by any spaces. Okay, so this is a 2D array if we wanted to. Write a program that prints a staircase of size n. Oh, okay. I don't even think we need an array. Like the data structure portion of it, I don't think we need. I think we could just hold a single counter and do this. So we could just move that down. Okay. So let's say for I is equal to 0. I less than n. I less than or equal to n, I plus plus. So this is going to go 1, 2, 3, 4. Can we just say like that times I? So can we say like hash times I? Is that possible? No. Okay, we could do something like that. Let's not look it up yet. Let's just get through this. Okay, so let's just run it. I mean, obviously this is going to be wrong. I want to see what this prints out. Yeah, I should have printed something I could see. Yeah, okay. So for each loop, we'll just say const spaces and const hashes. So the number of spaces is going to be n minus I. Because in the first iteration, well, n is always, let's say 6 in this case. And I will start at 1. And then hashes is what? Whatever's left over. Oh, hashes is I. So console log will say spaces always come first. And then the number of hashes comes second. These log on separate lines. So they need to be on the same line. Okay. Man, maybe this is easier to do in that array format. It's fine. We can just do... that. And then const hashes array is going to equal the hashes one. And so our output is going to be spaces array dot concat hashes array. And we'll join them up. And then you just log the output. Okay. Must have gotten something backwards here. Let's just figure it out based on the indices of the loop. Okay, spaces is wrong. So in the first iteration, I is 1, n is 6. In the second iteration, I is 2. Oh, it's n minus I. Yeah. I just got to get rid of the debug logs. All right, cleaning up the code a bit. Okay, and we'll submit. Sweet. Go back. Problem solving. Given 5 integers, find the minimum and maximum values that can be calculated by summing 4 of the 5 integers. Oh. Then print the respective minimum, and maximum values as a single line. Okay. Okay. So this bit me on a previous question. Instead of starting at 0 and calculating min and max. Oh, it's all positive. Okay, cool. So we can start at 0. If there were negative numbers, you need to use infinity and negative infinity as your bounds. Otherwise, like 0 doesn't work. So in this case, 0 is fine because everything is... Actually, let's just do it. The maximum sum is negative infinity, so that it starts at negative infinity, and then any number you get is greater than that. And the minimum sum is positive infinity. Anything you calculate will be less than that. Okay, so what we're going to do is we're going to loop through the array, and we're going to use slice or splice, I can't remember which one, to remove one item from the array and sum the rest. So we'll essentially just say, I better get used to using plain ass for loops. You know what I'm saying? Because that is the bread and butter in these things. So let I equals 0, I less than array dot length. And this will be the indices 0, 1, 2, 3, 4. I plus plus. Okay. So what are we going to do? Splice out element at I, calculate sum. Check min, check max. In this case, we'll just say like const sum equals 0. I'll just do this part. So if sum is less than min sum equals sum. And then same thing, but opposite. For max, if the sum is greater than the max sum, update the max sum. And at the end, we're just going to console.log min sum, max sum. Okay, so like the structure is set up. This is the slightly harder part. All right, so it's array dot just slice returns a copy of a section of the array. What about splice? Removes an element from the array. What does it return? An array containing the elements that were deleted. That's not what I want. What about toSpliced? The copied array. Great. That's what I want. So the spliced array is going to be array.toSpliced. The 0 base location from which to start removing elements. So that will be I. Okay, and then 1. Okay, so let's just log out. I want to log I. I don't want to log our spliced array. And so now we've got spliced array dot reduce. I always call this accumulator and current. That's the first argument. The second is going to be 0. And then what we're going to do is we're just going to say current index and array. Return the accumulator plus the current value. We don't need index or array. Does an array have a sum on it? There's got to be a way. Reduce. For each. No. Wow. That's fine. We'll use the reduce. We'll return. Okay, so that should be the sum. Okay. And we'll log out the sum. All right, see if it works. Oh. They're not going to let us use 2 spliced here? Because it's compiling it away? I mean, it certainly does. Okay, well, that's fine. So instead of doing this, we'll just ignore it in the reduce. So we'll say if index is the same as I, just return the accumulator. Otherwise, sum it up. So first it's going to go 2, 3, 4, 5, 9, 10, 11, 12, 13, 14. Yep, then 13, then 12, then 11, then 10. Yep. I like the splice version better. Okay, these are probably too easy. Okay, cool. Let's try a harder one. We define a magic square to be an n by n matrix of distinct positive integers from 1 to n squared, where the sum of any, oh my god, row, column, or diagonal is always equal to the same number, the magic constant. You'll be given a 3 by 3 matrix of S integers in the range 1 to 9. We can convert any digit A to any other digit B at the cost of A minus B. Okay, like the difference. What the fuck? Print the cost on a new line. Oh my god. Okay. I feel like the way to do this is to find the magic constant that is like most frequent. And then figure out how to make that happen. So let's just make a function that's like find find constants, and it'll take in the square. Okay. Okay, so let's do row constants. It's a double for loop. So we start at 0, I less than s dot length, I plus plus. No. Yes, no, yes, this is right. Yeah, because we're just iterating I. So so in this case, the sum is s of I of 0 plus okay. There's the row constants. Now the column constants. This is J, not I. So in this case, I changes. That's J. And in this case, I think we could just do these manually. So 0, 0 is here, 1, 1 is here, and 2, 2 is there. This case, now we got to do the other diagonal, which is 0, 2, 1, 1, and then 2, 0. Okay, so now we should have all of the constants. Ooh, this one's gonna be a toughie. I think as long as you break it down into steps, but I hope the most frequent constant is the one that we should choose. Because if there's ever a case where there's like an equal number of constants, or like you have to like one is cheaper to get to, I have no idea. Undefined, huh? Oh. 15, 15, 14. 1, 2, 3, 4, 5, 6, 7, 8. So 15, 15, 14, 15, 9, 5, 1, 15, 14. Another diagonals, 14, 15. Okay, so that works. Okay, so now we need to find the most frequent constant. Where did it go? Which was passing constants, which is an array of numbers. And we're going to return a number. So we'll have a new map of number to number. And then we'll say constants for each constant. And for each constant, we'll add it up, stick it in the map, and then we'll return the map that has the... greatest value. So for each constant, we'll say frequency. If frequency has that, then we say the value is what? It's frequency.get constant. And so if there's a value, you set it to, you set constant to value plus 1. Else you set it to 1. And now we need frequent constant is going to equal guess we have to iterate over this and see which one has the biggest one. What does entries return? An iterable? Okay, so we'll say let frequent constant equals undefined. We'll say frequency for each. If value key value comes first and then key. Value, key, and map. So if the value here is bigger than the value of that one, set it. Set the key. Oh, this is hard. I mean, yes, frequent constant is going to be, what's the problem? Can you show me some error highlighting, please? Find frequent constant. $48.30. It'll be a number or undefined. We're starting to come up on time here. This one's tough. One, 2, 3, 4, 5 of those. Need to see if frequency is correct, so it should be a map. Correct. That's right. Yep, that's correct. And so now all I wanted to say was if the value all right, where are we screwing up here? It should be right in here. That's why. Undefined was a stupid thing to put there. I should have gone with my negative infinity thing that I was doing. Where are we going wrong? Not at all, man. This one I'm finally tackling a harder one, and it's getting me. I'm trying to break it down into small steps. The issue is with this, the frequent constant that I'm holding. Oh, I need to like initialize this. So negative infinity isn't the right thing to do. I could just initialize it to any constant in the map. Would it make a difference? I can make it 0. I'm trying to count the frequency. So I've got this map, and I'm counting the frequency of the number 15. It showed up 5 times, and the number 14, and it showed up 3 times, and now I need to find the maximum out of these. I feel like there's got to be... Is the map the right way to do it? Frequency map. Count item with max occurrences. Yeah, I didn't know if the best way to do that was to loop through the map. Counts, max count. You could, oh, he's doing it in one pass here. Now he's doing it in 2 passes. Once summing everything up, and then once finding the maximum. That's what I was trying to do, is loop over the map. Okay, so let's just... Yeah, I don't know. Let's just start, though, with... I'll set the most frequent constant to be the first value in the map. Can I do that on an iterable? Problem is, when you work with those map data structures, I never know how to access some of the things in them. Yeah. Because why do I feel like you need another key after that? Why is it a string? This is a map of a number. Ugh, okay. I give up for now. I got an interview in 15 minutes. I like using maps and sets, but the problem is the minute you need to iterate over them, they suck. There's no easy way to just like... I don't know. Yeah, I got to dive into that a little bit more. But this one was pretty difficult. You have to find the sum that occurs most often of all the rows, columns, and diagonals, and then optimize that square at a given cost to fit that. You could use just an object instead of a map. I was trying to use the better data structures, but they're actually more difficult to work with. Then it's a whole lot easier. Yeah. Anyways, okay. I got to shut this down. Talking to Jeff this morning from Clerk. So I will catch y'all in a bit. Thank you for watching. Brian, thanks for showing up. Appreciate you. And hope everybody has an awesome day. I'll see you in the next one. Peace.